Okay, so we're still talking about implicit differentiation. So this will be our third example. So this one, not only does it have trig functions in it, but it's also going to use the chain rule. Okay, so we're just finding y prime, we're not doing the tangent of this one. So if I want to find y prime, okay, so this right here is using the chain rule. So the first thing we're going to do is we're going to find the derivative of sine, which if you remember your trig functions, the derivative of sine is cosine. So this would be the cosine of x plus y. Okay, then the chain rule says you do the derivative of the trig function, but then you also have to do the derivative of what's inside the parentheses. So if I do the derivative of what's inside the parentheses, the derivative of x is 1, and the derivative of y is 1, but since you're doing the derivative of y, you have to have your y prime or your dy dx. Okay. Okay, then the right-hand side, this is product rule. So you're going to have your f of x times the derivative of g. So the derivative of cosine, well, derivative of cosine is negative sine x. Then I have to do the derivative of the angle because this is a chain rule, so the derivative of x would just be 1. Plus, so we did f times the derivative of g, plus it's g times the derivative of f. Well, the derivative of y squared would be 2y. And then since you did y, you have to attach the y prime. Okay, so we found the derivative. So what you're going to do in order to find y prime is you have to solve for it. So the easiest way to do that is distribute, multiply together, then we're going to get the y primes on one side. So if I distribute, so 1 times all of this is cosine of x plus y. Then I'm going to take y prime times it, so plus y prime cosine of x plus y equals, okay, on the right hand side, y squared times negative sine x times 1 would be negative y squared sine x. And then if I multiply these together, this would be plus 2y y prime cosine x. Okay, so I want to get the y primes on the same side and everything else on the other side. So I like to have my y primes on the left. So this will stay. And then I'm also going to have to move this term over here because it has a y prime, so minus 2y y prime cosine x equals. Okay, so my negative y squared sine x stayed here. And then I needed to move this part because this doesn't have a y prime, so I would have subtracted cosine x plus y. So I got my y primes on the left, everything else on the right. So then you're going to factor out the y prime from both the terms on the left. So I would have y prime, and then this is cosine of x plus y minus 2y cosine x equals, now on the right hand side we didn't change anything. There's nothing really to factor out besides a negative, so you don't have to factor anything out. It's not going to make anything easier for you. And then my last step is I need to divide by what's inside. So cosine of x plus y minus 2y cosine x. Okay, now I know there's a cosine x plus y, cosine x plus y on top and bottom, but this is subtract with that, and that's combined with that. So since they have to look exactly the same in order to be able to cancel. So there's nothing you can cancel here. I mean, if you want to take away negative, then that would make that positive, positive, negative, positive. That'd be really the only thing you could simplify. So that means my derivative is negative y squared sine x minus the cosine of x plus y divided by cosine of x plus y minus 2y cosine x. So I used the chain rule, we did derivative of the trig function, we also used the product rule and the power rule, kind of all rolled in together to one. Okay, and then you're going to have to be able to find the derivatives of inverse trig functions. This is listed in this same section because inverses of trig functions would... Now, if I showed you all the steps on how you actually find that, you're doing implicit differentiation. I'm just going to give you what all they are, okay? So if I want to find the derivative of sine inverse, that is equal to 1 over the square root of 1 minus x squared. Okay, if you want me to explain why, I'd be happy to do that in class on Wednesday, if you want me to. Okay? The derivative of inverse of cosine is negative 1 over the square root of 1 minus x squared. The derivative of the inverse tangent function is 1 over 1 plus x squared. And then the derivative of the cosecant inverse function, negative 1 over x square root of x squared minus 1. Okay, these are listed in your book in this section. I will not make you memorize these. Okay, I may do an extra credit question where I say, like, how do you find this? So if you want me to explain on Wednesday, I'd be happy to do that in class, do one of them for you. It has to do with where sine, like where the trig functions on the unit circle, where they are constricted with inside is how you know what their answers are, and solving for the y using implicit differentiation. But I assume that most of you probably just wanted to know what they are and aren't really that concerned about how you find them. Okay? So you'll have to find derivatives of the inverse functions on your homework. It may be within the product rule or a quotient rule. Okay? So if you're finding the inverse sine function of sine x, this would just be what your derivative is. Okay, that will get you all the way through this section, so you'll need to do your homework that's listed on that paper. So the homework from section 3.5. Okay, and we're going to tentatively looking at this due on Friday. If we can't get it due on Friday, we'll talk about it then. Okay.